the industry is moving more from central inverters to string inverters.
Okay.
String inverters have floating arrays generally.
Yeah. What does it
So
mean to
then
be a floating array?
that means that you have no physical ground
Hmm.
to a pole, like so usually negative,
Yeah.
depending on which kind of modules you're using.
Hmm.
But then that also means that the modules are seeing negative 500, negative 750 volts DC at a time
Yeah.
in that string.
If you've been in the solar industry for the better part of the last decade, you've no doubt heard the term PID, but I bet a bunch of you, maybe most of you, are unaware of how PID is created or mitigated. You're just familiar with the term potential induced degradation. Today, we're going to go a little deeper. Hi, I'm Nico Johnson, the host of Suncast. We're live at the Suncast Media Zone here at the NABCEP Conference 2024. The Media Zone is presented by LG Electronics Energy Storage Systems. And I am here with Emily Hwang. Emily is the Director of Applications Engineering for Yaskawa Solectria Solar. I didn't realize that you guys had gone to using all three
Yeah,
words in the
we're
term
using
now.
all three of them.
Okay. I've been a Solectria fan since we installed Solectria 30 kilowatt, like completely stainless steel inverters for Target in Hawaii, like 2009.
Yeah, we started
So,
out in 2005 as
wow.
Solectria Renewables.
Yeah.
It's just been changing and evolving. 10 years ago, we got acquired by Yaskawa America.
Yeah, I did an interview with James Warden that was so interesting about the whole Solectria brand, how it started with electric vehicle
Yes.
and grew into a world-class inverter that eventually was acquired by Yaskawa. Emily, as an application engineer, you must touch a lot of interesting areas of the business. One of the things, candidly, that surprised me about work that you are doing is around potential induced degradation. PID has historically been, I would say, the bastion of solar panel manufacturers
Yes.
in terms of
Definitely.
a talking point. So for those that I may have alluded in the beginning, have sort of a cursory knowledge, would you give me a deeper understanding of PID?
PID is when we have a high negative potential difference between the cell and ground. So what happens with that is that difference actually creates a current or ion migration where all the ions kind of accumulate on the cell and lowers the efficiency of the module.
Lowers the efficiency of the module, and then how does that affect the system?
Well, if the modules are not performing as efficiently, then you have that loss in addition to voltage drop and all this other stuff. It lowers the productivity of your system.
Up to now, how have solar panel manufacturers across the gamut, how have they thought about PID from a mitigation perspective?
Yeah, they've done a lot, and obviously I'm from the inverter side of things,
Yeah.
but they've done a lot of research into different encapsulates, different glass, anti-reflection. They've worked to create standards in order to call themselves PID free, which means that they've tested and it has less PID effect
Yeah.
on their modules.
So effectively, we could say that no module is PID free.
Right. It's kind of like no insulation on cable is actually totally insulated.
Yeah,
right?
exactly. What intrigues me, of course, is why an application engineer at Yaskawa Solectria is so deeply knowledgeable about PID, other than just being understanding how the engineering of a system comes together. When did PID become a talking point or a topic that you needed to be concerned with?
Well, Yaskawa Solectria Solar started thinking about it when we moved towards 1500 volt DC
Okay. Yep.
systems, right? Because potential difference becomes even higher when you move to a larger
Yeah.
DC
Yep.
voltage. So we start talking about it. Hey, how can we do this? The industry is moving more from central inverters to string inverters.
Okay.
String inverters have floating arrays generally.
Yeah. What does it
So
mean to
then
be a floating array?
that means that you have no ground,
Right.
physical ground, to a pole, like so usually negative,
Yeah.
depending on which kind of modules you're using. But then that also means that the modules are seeing negative 500, negative 750 volts DC at a time
Yeah.
in that string.
At some point, as an inverter company, you have to think about the ways that you can improve efficiency across the entire system,
Right.
right? Is it true that one of the module manufacturers was looking at how to mitigate PID and came to you guys for advice?
Yeah. So First Solar, they are a thin film module manufacturer
Okay.
based in the States,
Yep.
and they wanted to have a U.S. manufacturing partner, um, inverter partner
Hmm.
that can work well with their modules
Yeah.
because their modules actually require PID mitigation 24/7.
Okay. So unlike crystalline PV modules, the thin film module doesn't have a way to reverse the process or the effects of PID overnight.
Right. That's
Okay.
right. They worked with a lot of central inverters, but then they realized the transition that was happening,
Uh huh.
and they realized they needed a string inverter partner.
And where does an inverter and a string inverter in particular create impact or benefit or mitigate in any way PID? How does that work?
Yaskawa Solectria Solar analyzed the different ways that inverters could help mitigate
Yeah.
PID, and we realized the most robust and resilient way was for us to ground the negative side,
Okay.
which
Right.
is unique for a string inverter topology.
To your knowledge, then it's something that that Yaskawa alone offers as a product.
That's right.
Okay. And the impetus for it, of course, was First Solar coming to you guys and asking for it. Is this something that is a sort of First Solar, which by the way would be enough for most companies? Is this like a First Solar only product? The way that like back in the day, SMA for they had the only inverter. They partnered with SunPower,
Right.
right? And they offered a positive ground inverter. The way that that SunPower's back contact would work with. Is it something similar to that, where this is sort of a First Solar only type of product?
No, not at all. Our customers will most likely want it for, let's say, the IRA production tax
Okay.
credits,
Yep.
right? Because you don't want your system, your 1500-volt system, to start degrading earlier than they think it's going to
Sure.
based on PID.
And so this could improve crystalline modules as well.
Oh, totally.
Okay.
Yeah.
Do you have any data on like levels of efficiency, or how do you measure the improvement or the relative efficacy of this opportunity?
So you can actually measure it. Our engineers went out, let's say, in Mesa, Arizona,
Hmm.
and tested on a First Solar testing site
Yep.
with our normal string inverters compared to our DCG line, which
Yep.
is DC grounded line. And they noticed that with our regular inverters, there was a significant decrease in production
Hmm.
compared to that. So we did actually like compare different topologies and see whether it would be more productive or not.
Emily, I really appreciate the extra insight into something that I think for many has become a bit of the back layer. Like the conversation that 10 years ago was really important. And many think, oh, this is a problem that has sort of been sorted, it's been figured out. If folks wanted to connect with you, is LinkedIn a good way?
Yeah, LinkedIn. We have the Yaskawa Selectria Solar LinkedIn, and
Yep.
also Emily Hwang,
And Emily Hwang. And
Hwang.
fantastic. And it is the URL Yaskawa Solectria Solar, or is it solectriasolar.com? Is that where do you normally send folks?
Oh, Solectria.com.
Solectria.com.
Yes.
Fantastic. You can learn more about all the fantastic products that Solectria is putting out into the world. And I would encourage you to connect with Emily if you have any questions in particular about the product that she is working on as an applications engineer. Emily, thank you for helping bring us to a new understanding of how PID and mitigation of PID is evolving in the industry.
Thanks for having me.